So here's some help on question 3. Question 3 looks a little intimidating at first, but it's really just a Henderson-Hasselbalch where you start out by solving for the molarity. So let's look at how we would solve that. So in question 3, it says, what is the pH of a buffer made from 25 grams of acetic acid, that's what that is, and 50 grams of sodium acetate dissolved in 1 liter of solution if the Ka is 1.8 times 10 to the negative fifth. So I brought that information over here, and I can't use grams directly. I'm going to have to convert this to moles. So I'm going to need to add up the molar mass of these two substances. And then, of course, we'll have 1 mole on the top to convert this to moles. So adding this up, hydrogen is 1.01 plus 2 carbons, which are 12.01. So 2 of those are 24.02, plus another 3 hydrogens, plus 2 oxygens, which are each 16. So when I add those up, I get a molar mass of 60.06. So 25 divided by that molar mass tells me that I have 0.416 moles of my acid. And then once again, I'm also going to want to add up the molar mass of sodium acetate. So 22.99 is sodium. 2 carbons would be 24.02. 3 hydrogens would be 3.03, plus 2 more oxygens is 32. So that my molar mass of sodium acetate is 82.04. So if I take my 50 grams times 1 divided by that molar mass, I find out that I have 0.609 moles of my sodium acetate. And now I'm ready to use the Henderson-Hasselbalch. Because these are both dissolved in 1 liter, I know that this is really 0.416 molar and 0.609 molar. Although remember that for Henderson-Hasselbalch, you can use either moles or molarity, so we could have, either way would have been okay. So Henderson-Hasselbalch, pH is the pKa plus the log of the anion over the acid. So putting this in, I'm going to have the pH is the negative log of the 1.8 times 10 to the negative fifth, which is our Ka, plus the log of my anion over my acid. So remember that when we put sodium acetate into solution, it just dissolves and sodium becomes a spectator ion, and we just have this anion. So remember, the one with more hydrogens is the acid, less hydrogens is the base. So I'm going to put the anion on top, divided by the weak acid. And when I put this all in, let's see. The negative log of 1.8 times 10 to the negative fifth is 4.74. 0.609 divided by 0.416 gives me 1.46. So if I take the log of that value, I get 0.166. And when I add those together, 4.74 plus 0.166, I get a pH of 4.91. Pretty straightforward. The only wrinkle in this problem was that we had to start by converting our grams to moles. Question 4 is going to be set up just like this, except that you'll need to start by converting your Kb to a Ka, and then just using the same problem solving. It's already in molarities, so it's a little less work. So I hope that was helpful, and I will stop for now.